September 12, 2025. A night that should have passed like any other begins with nothing more than the usual quiet hum of deep space. Stars sit still, galaxies glow faintly, and the universe seems content to keep its secrets. But then, almost without warning, telescopes across the globe light up with an alert. A streak, thin at first, almost shy, cuts across the darkness. It doesn't fit. It doesn't match any known object. And within minutes, astronomers everywhere realize they're witnessing something that simply shouldn't exist. Out of the void between the stars, a massive intruder is sliding into the solar system. Its tail spreads across the sky with a width so immense that astronomers compare it to lining up 5 full moons end to end. The images are overwhelming. This thing dwarfs every known comet of the modern era, even the legendary giants observers still talk about from decades past. While the world is still trying to wrap its head around what this first object is, a second one bursts into attention. From a completely different region of the heavens, another interstellar traveler is confirmed, designated SWC 2025 R2. 2 bodies. 2 different origins. 2 wildly different entry paths. Yet both aim directly at the same destination, the Sun. Experts scramble to calculate probabilities, and the numbers make no sense. The alignment is too precise. Too synchronized. Too impossible. Official statements quickly label them as comets, but off the record, the mood changes. Scientists whisper. Analysts frown at the data. The precision of these objects' motions feels less like coincidence and more like choreography, as if something unseen is pulling the strings. The first clues arrive from NASA's Solar Wind instrument that morning. It captures a streak so bright it momentarily overwhelms the sensors. In a field of placid stars, this object burns like a wound in the sky. Early measurements show that its tail stretches nearly 2.5 degrees wide. That is beyond extraordinary. That is unheard of. Even more stunning are the brightness estimates. Magnitude 7.4, visible to anyone with a cheap pair of binoculars. News spreads instantly. Amateur astronomers race outside, expecting disappointment. Instead, they find it. A glowing arc slicing across the constellation Virgo, impossibly long, impossibly steady. The images they capture begin circulating online, and each one seems more unbelievable than the last. Some barely fit the tail into the frame. Within 2 days, the International Astronomical Union confirms the discovery and names it C-2025 R2SW. Suddenly, the world is watching. Forums explode with theories. Students track brightness curves. Professionals argue quietly about composition and orbital anomalies. Nothing about it behaves like a normal comet, especially on a first approach to the Sun. And then the reminder hits. This newcomer is not alone. Just days earlier, the interstellar object 3I, Atlas had been confirmed. It came from the direction of Sagittarius, while SW traced its path backward through Aquarius. On any star map, these entry points are vastly separated. These 2 objects should have nothing to do with each other. Yet somehow, both are plunging toward the inner solar system at the same moment, and both will reach their closest passes within 3 days of each other. SW's perihelion is set for October 20, 150 million kilometers from the Sun. Atlas arrives on October 17, skimming just beyond 200 million kilometers. Their closest approaches will be separated by only 50 million kilometers. For reference, that's closer than Mars ever gets to Earth. Even stranger are their orbital tilts. SW cuts through space at a steep 60-degree angle. Atlas plunges in almost perpendicular to the solar system's plane. 2 rare, sharply tilted orbits, each coming from opposite directions, and yet both converging into the same narrow corridor of space at the same moment in time. Astronomers run simulation after simulation, and the conclusion is always the same. This doesn't just stretch probability. It practically shatters it. But the strangest twist hasn't arrived yet. As both objects rush toward their fiery encounters with the Sun, Earth's telescopes prepare to go blind. From October 8 to October 18, the Sun's glare will overwhelm every major ground-based observatory. The most crucial 10 days, the exact window when the anomalies might reveal their true nature, will be lost behind a wall of blinding sunlight. The timing is almost too perfect. Too precise. And it leaves everyone with the same unsettling question echoing in their minds. Is this really coincidence, or something far more deliberate? When the blackout period looms closer, astronomers push harder to gather data, and the results bring even more confusion. Atlas, the second visitor, begins showing hints of pulsing acceleration, tiny surges that don't match gravitational expectations. Not once but repeatedly. Almost like bursts of micro-thrust. SW, meanwhile, glows with a brightness so stable and so symmetrical that some researchers quietly admit it looks more like a controlled effect than a natural one. Together, these two objects are rewriting the rulebook. They don't behave like comets. They don't evolve like comets. If they are natural, they are unlike any natural body ever recorded. And if they aren't natural, then their arrival isn't random. Energy estimates add fuel to the fire. Atlas appears to carry the equivalent of 10 gigawatts, far beyond any drifting frozen rock. SW pushes past 10,000. That isn't passive. That's active. That's engineered-level energy. That's the kind of profile you'd expect from something capable of maneuvering. Theories erupt. Most are dismissed. A few refuse to die. One idea suggests the simplest explanation: a solar stopover. A scheduled recharge. A rendezvous designed around the natural power of the Sun. Spacecraft already use gravity assists and solar slingshots to boost velocity. What if more advanced machines use stars the way aircraft use fuel stations? Another theory carries a darker implication. A recovery mission. Perhaps one of these objects is damaged. Perhaps one is a carrier and the other an escort. Or perhaps both are pieces of a larger system, something humanity has no frame of reference for. Then there's the audit chain hypothesis. A pattern stretching back decades. 2017 saw an object arrive that defied expectations. Then Atlas. Then SW. 3 objects, each stranger than the last, arriving in sequence. Each one more complex. Each one after humanity's radio signals grew stronger and more widespread. If this is a chain, a pattern, then these objects aren't just visitors. They're responses. Meanwhile, SW's orbit offers a disturbing historical echo. Its 22,554-year cycle places its previous passage deep in the last ice age, when early humans carved symbols into stone and survived beneath miles of glaciers. Ice core samples from that era reveal sudden atmospheric disruptions, chemical changes that hint at dramatic sky events. Some researchers quietly wonder if SW could have played a role. Even more unsettling are the ancient carvings at Göbekli Tepe in Turkey. Stone pillars over 11,000 years old feature animal figures and strange sky markings. Some speculate they might represent celestial cycles. A few claim the patterns align suspiciously well with the path of a bright returning object. Most scholars roll their eyes at these claims. But the timing is hard to ignore. If SW did return during humanity's earliest known era of organized society, then maybe we've seen it before. Maybe we recorded it. Maybe we remembered it in myth. But just as these ideas gain momentum, the blackout begins. One by one, major observatories shut down as the sun's glare overwhelms their instruments. Space agencies cut off access to raw data. Internal memos leak, hinting that radar sweeps and high-resolution imaging have been quietly paused. Researchers attempting to request alternative coverage are told to stand down until after perihelion. It feels less like routine procedure and more like a curtain being pulled over something the public isn't meant to see. Yet the sky belongs to everyone. And not everyone is willing to wait. Bill Gray, a respected orbital analyst, posts a warning across forums and encrypted groups: keep observing. Keep recording. Don't let the blackout erase what might be the most important astronomical event of the century. His message becomes a spark. Small observatories in Spain and Portugal form a network to pool their sensors. Amateur radio enthusiasts repurpose weather satellites. Students in South America arrange night watches with rented equipment. In Eastern Europe, backyard astronomers coordinate to track every flicker of light near the sun's edge. Humanity, ordinary, curious, untrained humanity, steps forward to fill the void left by institutions. For a moment, the balance shifts. The most extraordinary celestial encounter of our age is no longer in the hands of governments or space agencies. It belongs to the people watching from rooftops, fields, balconies, and mountain ridges. And when the blackout ends, it might not be a professional observatory that reports the first reappearance of SW or Atlas. It might be someone standing in their backyard at dawn, camera pointed at the horizon, waiting for a glow to return. Because the truth is simple and terrifying: two anomalous objects have entered the inner solar system together. Their timing defies probability. Their energy output defies physics. Their trajectory defies chance. And their behavior defies every explanation astronomers have offered. What they are, why they came, and whether their arrival is accident or design, those answers remain somewhere in the space between fear and wonder, waiting for the moment the light returns and the sky